Mohammed Hashim. This is a Kotlin compiler for the Lox Programming Language. I will first showcase the compiler implementation, then I will go through each pass of the compiler in detail. First of all, this is a factorial implementation in Lox. It's just a function, a recursive function that returns a factorial of the past n integer. I will use it to calculate the factorial of 6. It should yield 720. The implementation is so easy. Lox.run, then I'll just pass it the factorial string. It could be a string or a file, doesn't matter. Just would print 720. Then I will run this and it prints 720. There is also an implementation for inheritance. It makes a class called donut and a class called Boston cream. It's a type of donuts, and you call super.cock, and it shall print fry until golden brown. Then it shall print pipe full of custard and cold with chocolate. I will run it.
A few inches later,
and it works. The compiler is very simple. It uses a recursive descent parser, but it separates the compiler passes in different files. So I'll first go through the grammar. I'll show the token type. We have a very simple and very common grammar found in Java, C# and language like this. We have special tokens and characters like parentheses and braces. We also have the bang and equal and comparison and logic operators. We have literals. We have special keywords like and, class, else, false, such, and a special end of file character. This is basically our grammar components. We use Elixir to scan these tokens, special tokens, and encode them into a special parse tree that really doesn't do anything, just a representation of these tokens in the source file. Really a simple mapping using Kotlin when expression and pattern matching. Handles special cases like comments and line breaks and stuff. Just a really simple Elixir. We have an identifier, we have a line comment, block comment, and so. And this is really a simple mapping for keywords. We also have a parser that uses this parse tree and generates expressions and statements. It's really just a glorified scanner, and it converts the parse tree, converts it to an AST, a higher level tree. It just goes through the tree, the parse tree, and maps it to a more higher level tree using the statement file. We have here the sealed class of Kotlin. We have higher level blocks and containers like classes and functions and blocks, while loops. We have special expressions too. Like a binary expression, a grouping expression, literal, and so all these sealed classes are used in our parser, and they are the main components of our abstract syntax tree. We have a really recursive implementation. It uses recursive descent. We have or, and it uses Kotlin's higher order functions and lambda expressions to generate this recursive tree. And it's really simple implementation. It's just a logical mapping of expressions, and it really translates to the grammar very well. We have every part of our grammar in a separate function that makes things very easy to read and to understand. We have our helper functions like shake, advance, and peek. We also have a special semantic analysis pass, and it's called the analyzer, or it's called the resolver here. We use it to semantically analyze our code to detect irregularities and other grammar mistakes that would pass through the parser, yet it doesn't make sense, like a class that inherits from itself. We also detect other uncommon mistakes like a break outside a loop. This stuff we don't want it to be detected in the interpreter. We want it to fail before the interpreter. Still a dynamic language, yet we have some error detection and semantic analysis before the interpreter pass. Such common errors like this: return of value from it. Oh, I'm sorry, there's a noise. Such errors like a return outside of a function. We also have our main dish, which is the interpreter itself. It uses the AST after all passes are successfully done, like the semantic analysis and the lexer and parser. Then it executes the AST directly. It runs some minor optimizations, but it really executes the statements in a direct way. You can literally see its statements for each. Then it's just a better matching. If it's a var, then it defines a new value in the environment. And then it goes like this for each single expression, statements and expression. This function, big function, just to evaluate expressions. Here you can see that I have used pattern matching instead of the visitor pattern of object-oriented languages like Java, for example. The reason is that visitor pattern can easily become a hurdle. It can so easily become so complicated. People often don't like the interpreter pattern or the pattern matching that I've used because it goes makes the function really big. And yes, this is understandable, but I think this is more verbose and more clear than having like setting up three files just to do the same thing. And it can get so big in the visitor pattern too. I think this matches more with the functional programming pattern that I've tried to use everywhere. We also have some helper functions like the boolean is truthy one, and some checks before doing number operations and stuff. And really this is so simplified. Our environment is a glorified table or a map or a dictionary, as you prefer to call it. It just has rules to accessing this map. It's really just a composite map with some helper functions like assign add, assign get, and also an ancestor function, because environment could be a child of another big environment, like a function in a class or a class on another class, or a function inside a function, because Lox have the concept of nested functions. We also have some errors for Lox. We have an environment error, we have a superclass called Lox error with some implementations like a resolver error, a syntax error, a scanner error. Also we have the concept of breakers because of the word break inside loops or the word return inside functions. So this is really what's in our compiler. I think I've covered all passes. We have our implementation of classes in Lox. We have a Lox class. It's really just a callable, just like a function, and it's a big function. We also have Lox functions. This is just a Lox implementation of a function, and this is really what there is for this compiler.